Class 4 is all about dynamics processing. And this is really where you take all the work that you've done with the equalization and you focus it. As I said before, it's a classic thing that in working with equalizers, they're generally done, additive EQ in particular, you generally do post compression because as you're changing it, it's not affecting the compressor. But what I found in my experience is that if you get the basic shape of the sound, you get rid of what you don't want in the sound first, and then you do a basic tonal shaping, right, of the sound, so it more or less has the frequency response that you want, but maybe it doesn't have the character that you want. Then the compressor will take what you've done with the frequencies, additive and subtractive, and kind of tighten it up. Compression is really simple. If you think about real-world compressors that like compress air, right? It takes a lot of air and it puts it in a small space, right? So when you hit the little cap, the air blows out really, really fast, right? And that's kind of what we're going at. So what we're really doing is we're compacting sounds so that they're more dense. The same amount of energy, more focused. How you apply the attack and release curve tells the speaker how to project the sound out towards you. So slowing down the attack will force the transient or allow the transient to pop through more prominently so that detail will come through and jump out of the speaker. Then the compression kicks in and adds density to the note or the tone of the instrument. If you have the fast attack on the compressor, then what it does is it actually pulls everything together more. So the actual instrument is more static. Compression, very simply put, is dynamic level control. So when we talked about the 3D sound field and we talked about how the volume moves things towards you or away from you, a compressor is dynamic volume movement. So if the transient peak is allowed to pass through more rapidly, then the sound is going to jump out towards you, and then the compression, when it kicks in, is going to suck the sound back into the speaker. With the fast attack, then the attack of the transient signal does not jump out at you, and therefore the object is more statically placed, and therefore it kind of stays back in the speaker. If you have a fast release with the fast attack, then what happens is the attack is muted to some degree, but the sound is still solidly in the speaker, right? So this stabilizes it maybe slightly behind the speaker. If you make the compression longer, right, the release time longer, it will receive the sound back farther in the speaker. And you can kind of play with this. So if the release time has movement that's musical, then essentially it's the equivalent of taking an instrument and making it breathe or move forward and backward in musical timing. And this adds what's called groove into a song. And so you can kind of play with this where you're actually controlling the sustain actively of an instrument and the way it transitions from note to note with the compression. And this is a really key principle of pumping and breathing. The most common form of pumping and breathing that you really hear is when you compress the big room sound on the drums, right? And you get it like, you get this real depth, right, with it, which is really amazing. And it really can add this incredible size to a drum kit when you do it right. And if you want that pumping and breathing movement to sound off in the distant, fast attack. And then you set the release time to a musical value so that forward-backward movement is going back and forth in a musical timing. And it's something that you just control the release, you don't look at the number, and you keep moving it until it feels right. Literally, that's what it is, right? And they even make compressors that have musical values for the release time, where you could set it to 8th note, 16th note, 8th note triplet, whatever, right? So you can play with it that way as well, at least as a starting place. And so this movement, this pumping and breathing, can also make something sound very immediate and upfront to you, right? And that is also another way with vocals, right? You can really over-compress, like really hyper-compress a vocal, and that compression brings up all of that low-level energy, right? That really adds a lot of presence and focus and detail to the sound. And then when you get it kind of pumping and breathing, it's almost like it's right in front of you, moving back and forth, like vibrating right in front of you, right? Who doesn't want that for their vocal sound? So very, very powerful, right? And then there is the, so we'll get into these basic compression techniques about how you move things, focus things, make things sound smaller, make things sound bigger, make things sound more distant, sound closer to you, right? And this helps so much, right, with how you work with the sound and enhancing the way you perceive it in its three-dimensional space, right, around the speakers, right? And we'll go into why you use vintage compressors. Like optical compressors have a very glassy kind of, will add like a shininess or a polish to a sound. Transformer-based compressors will add density and warmth, amazing for guitars and bass, right? And low-frequency keyboards, right? To add like real character, right? And focus on that low mid-range. So it's like dense and focused, but not muddy sounding, right? Using the tubes, right, that add the high frequency sizzle that adds height and the low frequency density, that so you're stretching the sound up and down, right, with tubes. And working with the different vintage compressors and understanding how they work and what components are part of them is really important to knowing what works and what won't work. Also knowing the different types of compressors, VCA compressors and FET compressors, and how they sound relative to the optical compressors, the tube compressors, or the transformer-based compressors. So they all have different sonic characteristics. Multiband compressors is like surgery. It's like it's basically a dynamic EQ. An EQ is basically a static volume control that's filtered within a particular frequency range. So it's like a level control, but filtered within a particular frequency area, right? A multiband compressor is a dynamic equalizer, right? In other words, you can pump and breathe particular frequency areas and move and limit particular frequency areas. And that's why it has like this surgical quality. So when you have a sound that sort of just, you can't EQ it into existence, you can't use a full bandwidth compressor and get it to pump and move the way you want, then you dig into the multiband world, and then you can kind of make the low frequencies kind of operate or move in conjunction with the high frequencies, and that allows you to really manipulate the particular aspects of the sound, right? And we'll get into using gates and expanders, right? And how, you know, using the different types of expanders, like upward expanders as opposed to just downward expanders, and low-level compression, and when you gate things, right? How you gate things, soft gates versus hard gates, right? And very important for effects as well. We'll get into some of that, right? So there's some dynamic processing, very powerful, really important class.